So, getting a little more specific, what types of data, that are typically collected by edge devices would be most valuable for a predictive maintenance application?
Mhm. Well, I mentioned vibration. That's an obvious
Mhm.
one, especially for a lot of rotating equipment, a lot of things with bearings and things like that that are likely to wear and then cause, sort of movement and things that something like vibration monitoring can detect those kind of things. You've got, you can measure acoustic things, so like noise that might be generated by machinery when it's going wrong. Obviously, things like temperature, oil. Viscosity, but also condition of oil. So whether you identify what particulates are in there to determine whether something's wearing in the oil. Um, so there's a lot of sensing technology, again, that's been available to do a lot of that, but a lot of it was done kind of offline in labs, and you go off and have to analyze that oil sample and then come back weeks later to tell you what you already
Mhm.
found out that
Yeah.
the thing was going to fail. But when you can do that kind of stuff in real time, then or
Mhm.
near real time, then you can start to really get some benefits. And even just simple things like usage data, like hours run for pumps, flow rates through pumps, things like that. You can start to do things like detect potential blockages or cavitation on pumps and things like that. Reduction in performance in equipment, for instance, you can start to see trends where things are starting to wear before they finally fail. So not only are you identifying things that could fail, but you're also identifying areas where you're losing performance capability, right?
Mhm.
So that you fix those things in and get better throughput as well. So it's not just about maintenance to prevent failures, but also maintenance to keep that performance at a high level as possible.
Yeah, I'm glad you pointed that out. That it's not just preventing failures, that it's, keeping up with planned expectations. Absolutely.
Right.
Yeah.
Right.
So just a minute ago, you mentioned resiliency, and I'm glad you brought that up because that's another topic like predictive maintenance that's become a big issue for manufacturers in recent years. And I've heard that edge computing can be a big benefit when it comes to reducing equipment downtime and improving response times to operational disruptions, as you've been mentioning. Can you explain how edge computing in particular helps in those areas?
I touched on something earlier, and let me elaborate on that a bit more. That because you're now doing a lot of this processing at the edge, at the process itself, then the if you think about the availability of the information network, you're minimizing that and maximizing the capabilities of what's there. So, for instance, if there is a disruption in, say, the wide area network or in the cloud or wherever it might be, you're much less likely to have that impact for the operation of the system because it's all localized. Um, and we see that now. Of course, recently we saw that CloudStrike incident, which took
Hmm.
out a huge amount of
Yeah.
infrastructure in one fell swoop. And of course, if you localize that infrastructure, especially in an OT environment where you're protecting against automated patches, then the likelihood of something like that affecting your operation is going to be reduced. I think I also wanted to mention as well. I mean, we touched on it when we were just talking about the different types of sensing, and of course, OEE I know is a big thing for your user base here to
Hmm.
talk about operational overall equipment effectiveness, and it's not just about resilience, but also quality and performance as well. And so I think all of those things, all three of those things, can be impacted by edge computing. So we talked a little bit about the resilience, affecting the availability side of the OEE equation. Production we touched on, where we talked about the finding these reduction in capability that you might have, and then fixing that before it gets worse. And then even quality. So one example I was thinking of was you can do a lot of image processing in production lines to look at quality of product that is being produced, and a lot of that image processing, a lot of processing intensive nature required there to do that. But of course, if you can do that at the edge, if you can use things like AI, and you can introduce, even if it's just a subset of machine learning type algorithms and looking at imagery, you can even identify quality defects as they start to appear as well. So I think the potential is huge. Again, the capabilities there, the technology is available. It's more about how you implement these things, the strategies you
Mhm.
do, and achieve is going to be the key thing, I think.